and welcome to this online revision session for AQA FP1, in which we were looking at the June 2011 question 6 on the topic of differentiation from first principles. Well, the first part of this question asks us to expand 5 plus h all cubed. So the easiest way to do that will be to use Pascal's triangle. So we know that when we expand this, we will get h cubed, and then an h squared, and then an h, and our final term will have h to the naught, which is just 1. Similarly, we get 5 to the power of naught in our first term, 5 to the power of 1 in our second term, 5 to the power of 2 in our third term, and 5 to the power of 3 in the fourth term. And then we've got to multiply by Pascal's triangle, which for the third row, being since we're working out the cube, is going to be 1, 3, 3, 1, and each of those terms will be added, and so if we work out the coefficients we will get just one lot of h cubed, and then we've got 3 times 5, which is 15 h squared, and 3 times 25, which gives us 75h, and then finally we get 125. Fairly evidently there, we need to obtain the correct solution to that part in order to obtain our 1 mark. Part B of the question, we are then given the equation of a curve, y equals x cubed minus x squared, and we've got to find the gradient of the line passing through the point 5, 100 and the point 5 plus h. So in other words, what they're asking us to do is to find the gradient of the chord between those 2 points. So we know that in order to find a gradient, we need the difference in y over the difference in x. So in this case, we need to firstly work out what the y coordinate is at 5 plus h. Our new point, well, we have to substitute 5 plus h in for x cubed and for x squared. Now we've just done the 5 plus h cubed part and obtained the 4 terms. So that is going to give us h cubed plus 15h squared plus 75h plus 125, and then we've got to subtract x squared, which is the 5 plus h squared. Well, if we square out 5 plus h, we know we're going to get h squared plus 10h, 5 times the h both times, plus a 25. So that is the y value at 5 plus h, and then from that we've got to subtract the y value at 5, which is 100. And then that has to be divided by the difference in the x values. Well, x is going from 5 to 5 plus h, so that is just the difference of h. If we now collect our terms together, we have h cubed plus, well, we've got 15h squared minus an h squared, which gives us 14h squared. And we have 75h, take away a 10h, which gives us plus 65h. And then we have 125, take away a 25, take away 100, so those cancel out. And all of that is divided by h. And so if we now divide through by h, that will give us h squared plus 14h plus 65. So this is our gradient between 5 and 5 plus h. And you see we found suitable values for P, Q and R as required. So in our particular case we can see, and it's probably worth you just writing down the fact that P is 65 and Q is 14 and R is 1. Now there were 4 marks for working that out. So for the fact we'd got the h cubed plus 15h squared here, and similarly we then subtracted this part and we've ended up with this expression here. Okay, we would get a method mark and a statement mark for each one of those. Okay. Using the correct formula is the key thing for obtaining that method mark. But then having the correct expression for the gradient would be worth 2 marks, and you'd lose a mark for 1 error at that point. Finally, in part 2 it then says use your answer to obtain the gradient at 5 plus h. So this is where you come back to the idea of letting h get smaller and smaller and smaller. So as h tends to 0, what happens to the gradient? Well, we can state that as h tends to 0, the gradient, well, what will it do? It will tend towards 65. Why does it do that? Because we know that as h gets smaller and smaller, h squared is tending towards 0 and 14h will tend towards 0. So you could probably worth stating that somewhere just underneath here. H squared is tending towards 0 and 14h is tending towards 0. And so our gradient is equal to 65 at x equals 5. Okay, 2 marks for this part. Firstly, for realising that you need to tend towards 0, let h tend towards 0 at this point in order to find the gradient at 5 is the one key fact you need to have stated, and similarly then to realise that the gradient is tending towards 65 as a consequence is the second thing, and that will give you your 2 marks. Hopefully you found that solution helpful. For more help with your revision, please go to the Further Maths Support Programme website.